Predicting products part 2 here. First video looked at decomposition and synthesis. Here, going to look at those last 3. First one, combustion. We haven't talked about this, but there's actually 2 types of combustion. The first one is the one we've talked a lot about, and that's complete combustion. And that's where, again, your reactants are carbon and hydrogen. Like I said, there may be some oxygen attached here, but there's definitely mixing with oxygen from the air, or if you have an oxygen source. And your products for complete combustion are always going to be CO2 and H2O. Always, always, always. And that's going to be true unless I say, or unless there's evidence to prove that it's incomplete. And this is where reactants, same as before, but your product's going to get water again, but you may end up with carbon monoxide. You may end up with just carbon, and here you see this as soot, or carbon dioxide as well. And it could be a mixture of these. Like I said, I will tell you, or your observations will show when that reaction is incomplete versus complete, and that's the only difference. Most of the time, if I don't say anything, assume complete. Next one, single replacement. This is where either your metals are going to replace your metals or your non-metals will replace your non-metals. You have to look at that single element and see, what type is it, who's it want to replace. And then we say, who does it want to replace, because sometimes it may not. So this, we have something called an activity series, and this is just a list of metals and then a list of non-metals that show who's more active, who's more active than who. And the reaction only occurs when the single element on the reactant side is more reactive than that counterpart. I gave this example here because we all know fluorine is the most reactive non-metal. So fluorine plus hydrochloric acid, HCl, we know fluorine is going to be able to knock chlorine off. So then what happens? Well, you end up with hydrogen bonding with fluorine, and then chlorine by itself. It's not balanced, but that's the idea. Is this guy more active than who he's trying to replace here? If so, it works. If he's not, it doesn't work and it doesn't do anything. And number 5 here, last one, double replacement. Here, think about it as switching the fronts or switching the back halves. They're both ionic, so figure out where that cut line is between your positive side and your negative side, and then just flip them. And then balance the new compounds based on those charges. Charges aren't going to change. So if it's an iron 3+ on one side, it's going to be an iron 3+ on the other side. Watch those solubility rules, and we'll make sure you get a copy of those to see if that new compound, well, is it aqueous and does it just kind of stay in the liquid, or are we producing one of those precipitates we saw in lab? And we can show that with an S afterwards, or that down arrow to show that it precipitated out of solution.